Let's see how generics prevent the problems we discussed earlier. So let's add a new class in this package. We call this generic list to differentiate from the other list implementation. Now, we want this class to be generic so we can reuse it to store different types of objects. So right after the name of the class, we type these angle brackets, and inside these brackets, we type a capital T, as in short for type or template. Now, we could use any letters here. It doesn't have to be a T, but T is a common convention. Another convention is E, as in short for element. We use that when we want to implement a class that acts as a collection, so it can store many elements. So here we could use either E or T. I'm going to go with T. Now, this T is a type parameter for this class. So just like our methods can have parameters, our classes can have parameters as well. This T over here represents the type of objects we want to store in this list. When we create an instance of this class, we'll have to specify an argument or a value for this parameter. For example, back in our main class, let me delete all this code. If you want to create an instance of our generic list, we type new generic list. Now here we specify the type of objects we want to store in this list. For example, user, or string, or integer, okay? So back to our generic list implementation, this T represents the type of objects we want to store here. Now we need an array of type T. So private T array, we call it items, and set it to new T array of 10. Now here we have a compilation error because the Java compiler doesn't know the type of T at this stage. Is it the character class or the string class or the user class? It doesn't know what it is. That is why it cannot instantiate it. Now, one simple workaround is to use new object array here, and then cast the result to T array. Okay? Now, just like before, we need a field for keeping track of the number of items in this list. So private int count. Next, we implement our add method. So public void add. Now, instead of an integer or an object, we pass T. The type of T will be determined later when we create an instance of this class. So we call it item, just like before. And here we store item in our array. So items of count ++ equals item. Finally, we need our get method. So public T get integer index. Again, instead of an integer or an object, we return T. Okay. So here we return items of index. Now, back to our main class. When we create a generic list of integer and call the add method, look, the type of this parameter becomes integer. So if I call this method and pass a string, I get a compile time error. This is the benefit of generics. This generic class ensures that every object in this list is an integer. Okay? Now, actually, let's store this in a variable called list, and here we call list.add. Let's pass an integer. Now here's the second benefit. When we call the get method, look, we get an integer. So if we get the first item, we can simply store it in an integer. And here we don't need an explicit cast. If we had a generic list of users, we could add a user object here. And when reading the first item, we would store it in a user object. Okay, again, we don't need an explicit cast. So our code becomes cleaner and we get compile time type safety. So we can catch our mistakes at compile time rather than at runtime. That is the beauty of generics. Now, over the next few videos, we're going to study generics in more detail. You're going to understand how exactly generics work under the hood. So I will see you in the next video.